We have seen mux implementation of pass transistor logic. We will wind up this session with some problems of pass transistor logic. In the first session, we have seen when cascading pass transistors. I am having a pass transistor. This is my input select line or control line A. This is my input. This I am placing it on 2 volt here. If VT, threshold voltage of this transistor, be 0.7 volt, so this output is 2 minus 0.7, this will be 1.3 volt. If more stages are there, again it comes down. If the next stage, the output will be 0.6 volt, because 1.3 minus 0.7, if I cascade one more stage. So there must be a level decline, there is a deterioration in level in the output, because it's an NMOS, so output will be diminished by a factor of the threshold voltage. So how this can be, this is a drawback of this pass transistor logic, and normally one thing how this can be eliminated, this can be overcome. So one technique is level restoration is one technique. Level restoration is one technique which demands additional hardware. Level restoration. So let us see, this is my circuit, this is my simple circuit. Let us see this. So this is my input E, this is my input C, this is my control, and you see in level restoration logic you have to have a CMOS NAND and you must make a PMOS in the feedback path, and this is VDD, again this is VDD, okay, this is VDD, this is my ground, this is my ground. So if this is my load capacitance CL, this must be connected like this. So this is MP, this is PMOS. So this forms, this is M1, this is M2, this is M3. You see, our problem is when a 1 is transferred, it will be having, output is detected by the threshold voltage. So how does it work? Simply it can be explained. If a 1 is transferred, if a logic high is transferred, this will be high, this will be high, this will be 0, this will be this output, this is an inverter, this inverter's output will be 0. Whenever this inverter output is 0, this is a PMOS, this PMOS turns on. This PMOS turns on, and this capacitor, this output capacitor, it charges to VDD. So your level which was decremented by the time VT, that will be replenished. So simply when a 1 is transferred, this is 1, this logic high, this is logic 0. So this 0 means this transistor MP turns on. So this transistor turns on means this capacitance, this output load capacitance, it will be charged. Earlier it was, this voltage was, if this is 2 volt and threshold voltage is 0.7 volt, as we have seen in the previous example, as I said. So this is 1.3 volt. So there is a reduction of 0.7 volt. So then what it does? This is 0, so this transistor turns on, this capacitor charges towards 2 volt. This capacitor charges towards, if VDD is 2 volt, it charges towards 2 volt. So this decline of 0.7 volt, that will be replenished by this circuit. So the level is restored. So this is one way of overcoming the problem posed by pass transistor logic. The other way is more simple technique. You see, this requires additional 3 transistors to overcome the problem posed by a single transistor. So There are other methods. One is a transmission gate logic is a way out for this level decline, level deterioration. So if we see it, transmission gate logic in our next session. Thank you.